1.33, right? So a particle of mass m and charge minus q enters a region between two charge plates, right? Initially moving along x-axis with a speed vx, like the particle shown in figure 1.33. Where is 1.33? So this figure, that is in question number 14. In question number 14, they have shown, no? So that is how there is a particle of mass m and charge minus q which is moving between two plates, right? The length of the plate is L and a uniform electric field E is maintained between the plates. Show that the vertical deflection of the particle at the far edge of the plate is given by this value, which is QEL square divided by 2m into Vx square. Okay, let's try to break this question into smaller parts and observe. So what is happening here is there are two plates. Okay, so let's say there is a positive plate, there is a negative plate, and there is a particle of mass m and charge how much? Minus q, which is present. It's not the coordinate; these are the properties of it, right? So it is given an initial velocity of vx, which is the velocity along the x direction. Now tell me one thing, you have a positive plate and negative plate here. How is the electric field going to be? Electric field is from the positive terminal to the negative terminal. It is going to be like this. So let me call this as E, right? Okay. So this distance is given as L, right? Now the important question is, when you have electric field like this, right? When you release this particle, then how is this particle going to travel? Is what the question is. So listen to this very carefully, okay? I just want to tell you something important. If I have the electric field present in this way, okay, I'll use another slide. See, if at all I have electric field present in this way, there are different possibilities where if you place a charged particle in electric field, what do I mean by place? Means it is at rest. So if the velocity of the particle is zero, listen to this carefully. If the velocity of the particle is zero and you place it in the presence of an electric field, it will experience a force. It will experience a force of how much value? It will experience a force of Q into E, which is going to be in the direction of electric field, right? If Q is positive, else opposite direction. Means if the charge is negative, it will experience a force in the opposite direction. Okay, that is fine. Next thing is, I can give a velocity to this particle. If I give velocity to this particle, what will happen? It will still experience a force either in the direction of electric field or in the direction opposite to electric field. Right? How did I give the velocity here? I gave the velocity along the electric field. Now comes the challenge. What if I make the electric field vertical like this, but give velocity to this particle, but in the perpendicular direction? As soon as it enters the field, what will happen is, it is already having its own velocity, due to which it will tend to move in the horizontal direction. But due to the electric field, it will experience a force in the upward direction, as a result of which it will start bending in a curved path. Now the question is, what is the curved path it is going to take? And the curved path is going to be a, any guess? What is the curved path going to be? Okay, but what is going to be the shape of the curved path? It will be, is it parabola or circular? It is parabolic. So make a note of this, because the similar kind of concept comes in electric field also. There it will not be parabolic, it will be something else, because there is a reason for it. Okay. So what is happening here? I hope you understood the whole story. When you talk about electric field, you have nothing to do whether the charge is placed, whether the charge is given velocity or not. It will move in the electric field, right? Only thing is, if you place it, it is going to experience a force. If you give it initial velocity in the direction of electric field or in the direction opposite to electric field, it will still experience force, but it will move in the same direction. Whereas if the electric field and the initial velocity are perpendicular to each other, what path will it take? It will take a parabolic path. Okay. So this is a very, very important point to be noted. Clear with this? Right. Now, what do we have to do with this problem? If you observe, what will happen? You have a negatively charged particle, and the electric field is from the positive to the negative terminal. So as soon as it enters the electric field, right, exactly perpendicular to it, what will be the path it will take? It will take a parabolic path. The parabolic path could either be in the upward direction or in the downward direction. In this scenario, how will it take? It would have taken in the downward direction had it been a positive charge. Here it is negative charge. What will happen is, I released it at the negative end. So it will repel due to the negative charge and it will take this kind of a path. Now, if you see the question, what they are exactly asking is, what is the vertical displacement that has taken place? What is the vertical displacement that has taken place at the other end? That's what they have asked, no? What is the vertical deflection? So how much has it got deflected from its initial position? Means our job is to find the value of y. It's very simple. Okay, whenever you have these kind of problems, right, where you're asked to find the displacement, use the equations of motion. What does it state? S is equal to ut plus half at square. So apply this initially along x direction. Sx is equal to ux into t plus half into ax into t square. What is the displacement that has taken place along the x direction? L is equal to, what is the initial velocity along x direction? They have given it. Vx into t plus, in this scenario, remember the particle will experience force only in the direction of electric field or in the direction opposite to electric field, right? All other directions, the force experience is going to be 0. When force is 0, acceleration is also 0. So electric field is confined to which direction? X direction or y direction? Y direction. So the acceleration along x direction is going to be a 0, right? So from this, can I say t is equal to L divided by Vx? Let me call this as 1. Similarly, if I apply the displacement along y direction, so Sy is equal to uy into t plus half into ay into t square. So what is the displacement along y direction? It is y is equal to, what is the initial velocity along y direction? 0, because it's given only along x. 0 into t plus half into, what is the acceleration along y direction? See, charge is there, electric field is there. What is the force experienced by the particle? Q into E in terms of magnitude, right? But we also know that force is equal to mass into acceleration. So what is going to be the acceleration along y direction? It is going to be Q into E divided by m. But here, yeah, Q is Q only. So take it and substitute it here. So it is going to be Q into E divided by m into t square. In the place of t square, I can substitute this L divided by Vx, the whole square. So what is the answer? Y is equal to QE L square divided by 2m Vx square. If I am not wrong, that is what they asked. Is that not the expression? That's it.